So here we have a function that calls memcompare, and expectedly it calls memcompare, jump memcompare. But there may be situations where it doesn't call memcompare. And those are if you usually have a size that is known at compile time. So if n is, let's say, 8, well, it will still call memcompare because memcompare needs to subtract s1 with s2 as the return value. So it just doesn't, returns 1 or 0. It can be negative or something depending on, s1 and s2. But if we ignore the return value, now in real code you're probably doing not memcompare or memcompare equals 0. Now we can see that it no longer calls memcompare, it actually does a compare keyword. And what's this thing? Well, since the compiler knows that we are always comparing 8 bytes in this function, and the compiler has built-in functions which it knows that they're not just function calls, they are functions which the compiler knows what the functions are actually going to do, in which case memcompare, here we're trying to compare s1 with s2, the bytes in s1 and s2. Now it compares keywords, so word is 2 bytes, d word is double word 4 bytes, keyword quad word is 8 bytes. It's the equivalent of this. So interpret s1 and s2 as 2 uints and just compare them. And why does this? Well, it's probably faster to compare 2 uints instead of doing a memcompare, because the CPU operates on words, not bytes, so it's faster to do this than do a byte loop. But it doesn't always do this. So if we go to another architecture, in this case we have x86 64, but if we go to, let's say, ARM, so in this case it's actually calling memcompare, and the reason for that is ARM, unlike x86 64 or other architectures, doesn't allow unlined access. And what that means is if s1 or s2, if the address is like 0x003 or something, where it's not aligned to the word size, let's say the word size is 8, so it's not like 0xx8 or 0xx16, it's actually undefined behavior. So the architecture can do anything it wants. If you try to access unaligned data, so in this case the compiler will not treat these two as 2 uints 64s, because you can. So say you have 2 long strings and you're trying to compare them for equality. Well, for architectures that allow unaligned access, it's probably faster to do something like this. So memcompare with a known at compile time size. So it's gonna compare the first 8 bytes, and then after that you actually call the memcompare there. So instead of calling the memcompare, you check beforehand that the start of the string are actually equal. But again, this will not work if the arch doesn't allow online access. So you may want to do like an if so if it has online access, so in this case, if you have an arch that allows online access, it may be potentially faster. So hopefully that makes sense.